discuss the final example, which is this one here. The question is x dy dx minus y equal to x. And then you are given extra information, y1 is equal to 2, which is later on you need to use this to find c. When x is equal to 1, your y should be equal to 2. So let's focus here. This is the question given. However, you can see that this is not in the correct form yet, because the correct form should be dy over dx plus pxy equal to qx. This is very obvious. The first term is not in terms of dy over dx. So since you have x here, you need to do something. You need to rearrange. So let's divide both sides here with x. Okay, so let's do it. Divide both sides with x. So you'll have dy over dx minus 1 over x y equal to 1, because x divided by x is equal to 1. So now we are ready to compare our equation here, because this is in the form that we want. So now let's identify what is our px and qx. So px is the whole term here minus 1 over x. And your qx is the whole term on your right hand side, which is equal to 1. So we're finished finding our px and also our qx. Now for the next step, we need to find mu, our integrating factor, which is e to the power of integrate px dx. So let's do this. E to the power of integrate px dx. Substitute our px here. Now let's focus to integrate this. Minus can be put outside. So integrate 1 over x is just minus ln x. Okay, we can just drop the modulus sign, because in chapter 5 we assume that all the variables are positive. So now we need to simplify this. We know that e to the power of ln im is equal to im. However, we have minus here, so let's bring this minus up. Okay, so you have e to the power of ln x to the power of negative 1. So e to the power of ln im is just im. Therefore, this is your mu. Your mu is equal to 1 over x. So we have finished finding mu, our second step. Now let's focus to our third step. Rewrite your question and multiply both sides with your mu, which is 1 over x. So this is it. You have 1 over x dy over dx minus 1 over x squared y equal to 1 over x. So now let's rewrite our left hand side in terms of d over dx mu y. Okay, so just rewrite this, d over dx, and then your mu is 1 over x y, and then just rewrite your right hand side. You can always check this if you want to see if this is correct or not. You can expand using product rule. Keep 1, differentiate 1, plus keep another 1, differentiate another 1. Okay, so this is always correct if you follow the manual given here. Now we're finished with step number 3. So now let's focus to do step number 4, which is rewrite this, and then let's integrate both sides. So rewrite your equation just now, and then add up the integration sign, integrate dx. For your right hand side also, integrate dx. So as I mentioned before, this is all drama. No calculation should be done here. Antiderivative, mixed derivative just cancel out. So this is just 1 over x y. And for your right hand side, integrate 1 over x dx. This is just ln x plus c. Okay, so you can just drop the modulus sign. And then we need to solve for y. So your 1 over x here, let's cross multiply. So you have y equal to x ln x plus xc. Now let's fill in our extra information that we got. X is equal to 1, y is equal to 2. So this will be used in order to find your constant c. So let's do this. Your y is 2 and your x is 1. So 1 ln 1 plus 1 times c. So let's solve this. Ln 1, this is just equal to 0. And then we'll have c is equal to 2. And finally, when we have c equal to 2, we can back substitute in our general solution just now. Therefore, our particular solution is y equal to x ln x plus 2x. Therefore, this is our final answer. So this marks the end for our syllabus for Math 3. I hope each and every one of you have a pleasant journey following my YouTube channel. So in case you have any question, you can drop in the comment below. So that's all. I wish you all the best for your final exam and for your future. Assalamualaikum warahmatullahi wabarakatuh.